100, before I give you the title of the lesson, let's look at a right triangle where this side is 2 and this side is 5. How do I find how long the hypotenuse is? Leg, leg, hypotenuse. What do I do? What's the formula? Yeah, we're going to do all the work. So we've got a squared plus b squared equals c squared. And then you said you define a as 2, b is 5, c I don't know. So 2 squared plus 5 squared is c squared. 4 plus 25 is c squared. 29 is c squared. The square root, I get the square root of 29 equals c. 29 is a prime number. There are no factors. So what is the length of that hypotenuse? Equals not c squared, but c. This side is the square root of 29. That is a legit number. That's a number, square root of 29. And that's where we get to the title of today's lesson. Now, today's lesson is on 2 parts. One, estimating square roots. And the other part of this lesson is irrational numbers. Square root of 29 is an irrational number. Okay? What is it about equal to? And that's what we want to look at. So the way we explore what it's about equal to is we think about our perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared is 36. So 29 is somewhere between 25 and 36. Agreed? Do you think it's closer to 25 or closer to 36? Okay, so is it closer to 5 or closer to 6? Closer to 5. So now what we can do is we can do something called a cut and try method. So let's look at 5.1. Now let's do it over here. 5.1 squared. Now I'm going to go ahead and save us some time. I'm going to do that on a calculator, so you don't have to multiply that out right now for this purpose. But 5.1 times 5.1 is 26.01. Do we need to go higher or lower? So let's do 5.2 squared. 5.2 squared is 27.04. 5.3 times 5.3 is 28.09. So now 5.4 is 29.16. 16. Okay. So now we know that 29 is somewhere between 5.3 and 5.4. Do you think it's closer to 5.3 or closer to 5.4? Closer to 5.4. So here's what I'm going to do. I'm going to start at 5.39 squared. 5.39 times 5.39 equals 29.0521. Too high or too low? It's above 29. So let's go down one. 5.38. So 5.38 times 5.38 equals 28.9444. What's it closer to? 5.39 or 5.38? 5.38, it's 0.0556. This is 0.0521. So it's actually closer to 5.39. So what we found out is the square root of 29 is about equal to 5.39. Is approximately what it is equal to. Does that kind of make sense? Okay. So then as we look at what we have, we take care of doing this. Let's define an irrational number. To be irrational, it cannot be written as a ratio or fraction of integers. It is a non-terminating, non-repeating decimal. So it doesn't repeat and it doesn't stop. That's an irrational number. So if we have all of our, let's say our real numbers are represented by this box right here, the real numbers can be divided into two categories: rational and irrational. The rational numbers include all those other ones we know, because integers, whole numbers, counting numbers, all of those rational numbers, all of those can be underneath here. Make sense? So what we're looking at is just the irrational numbers. Now, it helps us if we think about what our perfect squares are. Okay? The counting numbers that are perfect squares would be 1, 4, 9, 16, 25, 36. And we can keep making this list. If we made this list 36, 49, 64, 81, and 100. 1 squared, we got 2 squared, we got 3 squared, we got 4 squared, we got 5 squared, we got 6 squared, 7 squared, 8 squared. That's what makes them perfect squares. That also supplies to us the information that the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4, and so on. 25 is 5. So this should all be reviewed. So when we're looking at what we can really kind of do with these, what we're looking at is we can look at, okay, for our estimating purposes, we went to the hundredths. The book's really going to just ask you to go to the tenths, okay, or even the ones. So if I look at this and I say, okay, what about the square root? What about the square root of 50? Square root of 50 is between what two numbers? Yeah, the square root of 50 would be between 7 and 8. And that's really what they're going to ask. The square root of, let's say, 73. What's the square root of 73? Between. Well, what about the square root of 200? Our list goes all the way to 100, right? So watch what we can do with this. We know that this is the square root of 2 times 100. We know it can become the square root of 2 times the square root of 100, which is 10 square root of 2. What's the square root of 2 equal to? About. It's between what two numbers? 1 and 2. So does the square root of 200 become between 10 times a number between 1 and 2? Let's think about how it works. Let's take another approach here as we look at this. I know that 11 times 11 is 121, right? So if I think about those, that's 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. So what's it between? Yeah, it's between 14 and 15. So somewhere between 14 and 15 lies that number. Does that make sense? So let's do one more estimation of like we did square root of 29, we estimated to the 100th. Let's do the same thing. I'll use the calculator again to find out the numbers. You just talk me through what that number is. Let's say we have the square root of, let's pick the one we picked, 73. What two whole numbers is the square root of 73 between? 8 and 9. Okay, so we need numbers between 8 and 9. Where would you like to start? 8 point what? Yeah, let's start in the middle. If we start with 8.5, it'll tell us kind of directions we're going. So 8.5 times 8.5. I'll write that down as 8.5 squared is 72.25. Is that a pretty good guess? What's my next number I should test? Because if I go 8.4, I'm going to get smaller. I need to get closer. So 8.6 squared, 8.6 times 8.6 is 73.96. Is it closer to 8.5 or closer to 8.6? Yeah, this is 96 hundredths away. This is 75 hundredths away. So now we pick a hundredths place. So 8.5 what? Where do you want to start? I'm not starting in the middle. 8.55 times 8.55 gives me 73.1025. Too high or too low? So we should go lower. That was 8.55. 8.54. 8.54 times 8.54. 72.9316. Which one's closer? 8.54, because it's, if I go here, it's 7 hundredths away. This is 1/10 away. So square root of 7.3 is about 8.54. Now if I pull out that same calculator and I actually hit the square root button, because calculators have an amazing thing called the square root button, the square root of 73 comes out to 8.544003745 and it's going to keep going and going and going and going. Does that make sense? Easy enough? All right, so, I mean, this is what the problems in homework are going to look like. I'll actually write down A. You can use black. A is square root of 7. B is the square root of 70. C probably is square root of 700. Yep, C is the square root of 700. What two whole numbers, not even decimals, are these numbers between? Square root of 7. What's it between? 2 and 3. 70. Because 64 and 81. Between 8 and 9. 700. We might have to pick some numbers there, right? Because it's off our chart. What do we want to start with? What do you want me to... 20 times 20 is 400, so it's got to be higher than 20. 30 times 30 is 900. 25 I hear. 25 squared, I know that one is 625. Higher or lower? 26 squared. I don't have that one memorized. 12, 15, 0, 0, oh, nope, 12, 5, 6, 7, 676. Should we do 27? 27 times 27. 49, 14, 189, 0, 14, 5, 9, 12, 5, 6, 7, 729. So square root of 700 between what two whole numbers? 26 and 27. That'll really be about the extent of it. Okay, so we look at F. $90-degree angle, 1 and 1. How long is my other side? How long is the hypotenuse? What's the formula? A squared plus B squared equals C squared. A equals B equals C equals. A is a leg, B is a leg, C is the hypotenuse. So 1 squared plus 1 squared equals C squared. 1 plus 1 equals C squared. 2 equals C squared. Square root, square root. Square root of 2 equals C. So x equals the square root of 2. Okay? Don't let this one screw you up. But I'm going to give you G. G is 2, 1, y. This is the 90-degree angle right here. Use the Pythagorean theorem from yesterday to tell me how long y is. How long y is. When you got it, you can say. Noah, what's the formula? A squared plus B squared equals C squared. A equals B equals C equals. Kyle, what's A?
1.
Someone, what's B? Y. Because it's a leg. B is Y. C is 2 because C is always the longest one. So 1 squared plus y squared equals 2 squared. 1 plus y squared equals 4. Subtract 1 from both sides. y squared equals 3, square root, y is the square root of 3. Y is the square root of 3. What'd you have?
I put y equals 3 on the square root.
Ah, 3, 3. You understand why it's not 3? 3 would have been if this was the square root of 9. Right? Because the square root of 9 is 3, y squared can't be 3. Got it? Perfect. Have a seat. So, I'm going to play the Wizard of Oz error for you. See if you know what's wrong with it. See if you can catch what's wrong with it. I'll play it. We'll finish practice problems from yesterday. Here we go. Did you catch it? Emerson?
He said isosceles triangle, not right triangle.
Yeah. The sum of the square root of the square root of the sum of the square of the sides of an isosceles triangle equals the other side. Two things wrong with the one, it can't be an isosceles triangle, unless it was the one we did, the 1, 1, x. Has to be a right one, and it's not any of the sides. It's leg, hypotenuse. Okay? So, thank you, Scarecrow. Even with the diploma, you're not that bright. So let's take a look at yesterday's practice now. Let's go back to page 689. Back to page 689. And they've got a couple triangles for us. Triangle A, use the Pythagorean theorem to find the length of A. 26, 24A. So that's what we've got right here. 26, 24A. This is my right angle. Libby, what's my formula? A squared plus B squared equals C squared. A equals B equals C equals, in this problem, what's A? It could be, what two numbers? A or 24. I'm going to keep A as A. B then is, and then C is the hypotenuse, which is 26. A squared plus 24 squared equals 26 squared. A squared plus, just a little bit ago, didn't we do 24 times 24? No, we started with 25, right? It was 625. What's this 26 squared? 676. So we don't have to do that math again. I know that is 676. If I don't know 24 squared, we can multiply it. 16,908. 4, 6, 7, 5. 576. Get A squared by itself, we subtract 576 from both sides. A squared equals 100, square root, A equals 10. Once you know the formula and you can plug it in, it becomes fairly easy. Okay, so problem B. We got, this one's set up a little bit weird. 9, 12, B. So if I have A squared plus B squared equals C squared, A equals B equals C equals, what's A and B and C in this one? Elena, you weren't here yesterday. What's A? You have a disadvantage. What's A? A would be 9. I would agree with you. Or, oh, and what would B be? Oh, because A and B are the two that make the right angle. So B becomes 12, C becomes B. Doesn't matter. Now, we substitute. 9 squared plus 12 squared equals B squared. 81 plus 144. 225. Square root. That's 15. B is 15. C. These directions are a little bit different. I want you to answer C. Stand when you've got it. So following the Pythagorean theorem, I got 10 was equal to C. What did the question ask for? The perimeter. And label? Pythagorean theorem. Make sense? Excellent. Have a seat. Man, I don't think that projector's running well. It shakes a lot more than the other one, doesn't it? Okay, let's look at the last one. The last one says, which triangle below is a right triangle? Show your work, defend your answer. By showing your work in the book, they're going to ask you from time to time, is this a right triangle? How do you know? In order for you to answer those questions, get full points, you're going to have to use the Pythagorean theorem form. So there's A. Here comes B, 9, 12, 15. C, 10, 9, 4. So we're going to use the Pythagorean theorem for all of them, guys. I'll give you this little shortcut. A squared plus B squared equals C squared. A equals 10. B equals 10. C equals 20. A equals 9. B equals 12. C equals 15. A equals 4. B equals 9. C equals 10. And we substitute them in. 10 squared plus 10 squared equals 20 squared. 100 plus 100 equals 400. 200 equals 400. You should have been able, if you've noticed, would this even make a triangle? This 10 plus this 10 would be 20, so it would almost look like they would be right on top of each other. There wouldn't be enough room to even make a triangle with those dimensions. We proved it, doesn't work. 9 squared plus 12 squared equals 15 squared. 81 plus 144 equals 225. 225 equals 225. This one right here is 4 squared plus 9 squared equals 10 squared. 16 plus 81 equals 100. 97 equals 100. That one's close. So it's only B. B is a right triangle because the Pythagorean theorem works out true. Any questions on the two lessons we looked at today? No? Excellent. Excellent, excellent. All right, so